Good afternoon, everyone, and good morning to our colleagues joining us from the UK. So welcome to our seminar 3, the third and the final seminar in the UK Vietnam TNE webinar series on emerging technologies, jointly organized by University of Information Technology, Vietnam National University, Ho Chi Minh City, and the Middlesex University, London. Under the British Council Going Global Partnership 2025 program. I'm Dr. DUNG from the Faculty of Computer Networks and Communication here at UIT, and I will be your host and moderator for today's section. Over the past few months, this series has taken from quantum computing in Seminar 1 to 6G and intelligence meta surfaces in Seminar 2. And today, we close the series by looking at how digital twin and artificial intelligence can help make 6G a reality. So we are truly delighted to have you with us today. Whether you are a student, researcher, academic, or industry professional from the UK, from Vietnam, or elsewhere in the world, thank you for joining us. And very warm welcome to our speaker today, Dr. Antonino Masaracchia, from who's kindly joined us today from United Kingdom. Dr. Antonino, it's wonderful to have you with us. So before we begin, a few housekeeping notes. So please keep your microphones muted during the talk to minimize the background noise. You are welcome to turn on your camera on or off as you refer. We will have a Q&A section after the main talk. Please use the chat function to post your questions at any time during the talk, and we will address them in a Q&A segment. Today's section will be recorded and made available online after the event. Before we move to the main talk, I would like to say a few opening words on behalf of the organizing team here at UIT. This webinar series was established to bring the frontier research in emerging technology, quantum computing, next generation wireless networks, and digital twin directly to our students, researchers, and colleges through close collaboration between University of Information Technology and the Middlesex University, supported by British Council Global Partnership Programs 2025. Across the two earlier sections, we had a wonderful engagement from the student researcher, both here in Vietnam and internationally. We are confident today's closing section will be just rewarding. And now, it's my honor to introduce our distinguished speaker for today's seminar. Today we have Dr. Antonino Masaracchia. He's a senior member of IEEE and is a lecturer in computer science at Queen Mary University of London. He received his PhD in electronics and telecommunications engineering from the University of Palermo, Italy. In 2016, from 2018 to 2024, he was a research fellow at the Center for Wireless Innovation at Queen's University Belfast, which is the largest research base in physical layer wireless. As a part of communications system research group at Queen's Mary, Dr. Antonino research focus on optimal resource allocation for ultra reliable and low latency communication in 6G networks, digital twins-based solution, AI and machine learning techniques for real-time optimization in wireless networks, in UAV and RIS-assisted communication. So he has authored and co-authored more than 50 books, book chapters, journal articles, conference papers, and he has been invited as a keynote and tutorial speaker at numerous international conferences. He currently serves an area editor of IEEE communication letter, and he has received the Best Paper Award IEEE IWC MC 2023 and INISCOM 2024. So today, Dr. Antonino will present a talk titled How Digital Twin-Based Architectures and AI Can Make 6G a Reality, Potentialities, Application and Challenges. Dr. Antonino, we are truly honored to have you here with us today. Please go ahead. Antonino.
Okay, thank you very much. Good afternoon and good morning to everyone, depending on your time zone. Just before we start, sorry, but apparently my laptop needs to restart. There is no way that I can snooze it. If you can wait, just a little restart and I will gonna join. Is this okay? I'm sorry, it decided that it needs to restart, so there is no way that I can snooze it and avoid this mandatory restart. Is that okay, DUNG? Sorry for that.
You couldn't see the screen?
No. My laptop need to reboot and I cannot avoid that, so
yes,
before
yes, please go ahead, Antonino.
yeah,
Please,
okay, thank you. I will join
Thank you,
soon.
thank you.
Sorry for that. Sorry.
That's fine. That's fine.
Sorry. Oh, wait a second. Otherwise click cancel. Oh. Yeah, sorry. I'll be joined soon. Yeah.
So to the audience attendees, feel free to type any questions, any comments about the talk during the presentation. So we will address your question in the Q&A segment. So feel free to type anytime when you have any question, especially the student you are working on digital twin technology. So here we have some student, we have most of students from UIT. So I see, and
Hello, good afternoon. Sorry again, I'll be back. I'm back again. Can you hear me?
Oh, yes, thank you.
Yeah, yes,
Okay, sorry, but if I wouldn't restart, it would restart automatically. This is every Monday, this is what happened to the laptop. Sorry for that. I don't know how to avoid that, but that's okay. So thank you very much again, everyone, and DUNG for inviting me to deliver this talk. And very honored and delighted to do this talk today. So I'm gonna start to share my screen. So we already lost some time, so I will try to. Can you see my screen right now?
Yeah, we can see it.
Oh no, wait a second. What happened? Let's see.
Can you? Yep.
Can you see the? Yeah,
Yeah.
I saw now
nice.
full screen right now. Can you see everything?
Yeah, this is nice.
Okay.
It's nice. Yeah.
Okay, thank you very much again. So today, as I introduced before from Dr. Dang, I will gonna deliver you a keynote on how digital twin-based architecture and AI can help to shape 6G networks and make it a reality. So I will gonna talk to you about the potentialities on digital twin and AI, what are the potential application and the challenges that needs to be addressed in order to make possible the delivery of 6G networks. Why is not moving? Okay, now, okay. So this the outline is what we can skip. So basically, I'm gonna give a brief introduction about the CSR group. So I'm a lecturer at Queen Mary University of London. In particular, I'm a lecturer, and I joined Queen Mary University of London back in 2024. So nearly 2 years. The CSR group, which stands for Communication System Research Group, is composed from 9 tenure lecturers, which include 3 full professors, 3 senior lecturer and readers, 3 other lecturers, and more than 40 PhD students and postdoc. We have received a great amount of money to research, in particular 2 million of pounds sterling in terms of to conduct research activities, and by publishing more than 500 top tier journals like Transaction on Wireless Communication, Transaction on Communications, and the QMUL team, in particular the CSR group, has been invited to several high prestigious conferences like Globecom, ICC, and received the different best paper awards. This is the research group. For those who are interested, I put the QR code that directly will gonna redirect you to the CSR group. The head of group is Professor Nalanathan. Maybe some of you already knows him. And these are the other professor on the top, and Professor Yang-Wei Liu, since you had the previous seminar, was my understanding, was on reflective surfaces. He has an extensive experience in this field. And then myself, who is there on the bottom on the red box, and some other lecturer as well. So let's start with a brief introduction of what is the problem and why we need the 6G communication. So in the last 20 years, more precisely in the last 10, 15 years, we are experiencing a high request, so a widespread of mobile smart devices and services, which, as you can see from the graph below, this have increased very linearly in the last 10 years. And this was like our statistic back in 2020, but this has the increase of these smart devices has brought an exponential increase of traffic demands from mobile users. So even though the 5G networks has been able to address some of these requests, there is a need for the deployment of a next generation networks, which, as most of you knows, is referred as 6G networks. So the 6G networks is expected to improve the current networks in terms to address the capacity and address more and provide services to multiple users. But in addition to that, is expected to provide and push further the boundaries and the performance of the networks. So as you can see here on the top, there is a circular graph which compare the requirements of the 5G, which is the inner box inside, in terms of reliability, possibility of connecting a certain amount of users, latency, energy efficiency, and user experience. So the 6G is expected to push further these key performance indicators, which are necessary to deliver new life-changing services like a UAV application or holographic application or extended reality of telemedicine. So, and in particular, the main focus for the 6G, so based on this graph, is the deployment of ultra-reliable and low latency communication, which means guarantee latency communication between transmitter and receiver, which is below 1 millisecond, so sub-millisecond communication latency, and error probability, which are very low, so reliability, meaning that the channel must be nearly error-free. So, and these are necessary for a lot of services like metaverse-based services like holographic communication or tactile internet, which requires very low latency, or the latency plays a more important role on smart manufacturing and autonomous driving. So imagine if there is an autonomous driving system that the latency is not guaranteed, and this will gonna compromise the coordination between autonomous driving system, which can create serious harm and very threatening condition for the surrounding environment. And also the ultra low latency communication and reliable communication are very essential for the deployment of the visionary smart cities, where everything is connected and communicate to main central services. So in summary, there are going to be a new plethora of service provided like education and entertainment, intelligent transportation, e-health, and smart manufacturing. So, and these are the potentialities that will gonna be unleashed if we are able to unleash the ultra reliable and low latency communication requirements. But at the same time, there are going to be some challenges to address, which are this energy and spectral efficiency, because in particular the spectral efficiency, because the spectrum has been reduced and is very scarce resource at the moment. And there is the need to either improve the efficiency on how we use the spectrum, or the possibility of exploring the new type of bandwidth to transmit. And also increasing the network throughput, because some of these services, in particular for the smart environments and intelligence and the IoT services, requires a very high throughput and network availability. So, in summary, the 6G is expected to provide a new life-changing services, so that we're gonna change our everyday life. So, on the ground, on the terrestrial sides, these are services on the terrestrial sides. So once these are deployed, the disruption of the network, what will gonna happen? Any disruption can lead to serious socioeconomic consequences. So there is the need of have a good availability of the connection. So we should not rely only on the terrestrial network, but recently has been pushed the possibility of investigating how we can deploy non-terrestrial network, which means UAV communication and further satellite communication. These are common, complementary, and redundant links that can provide services in case of a disruption of the terrestrial network, provide coverage during emerging scenarios, and extended coverage in remote areas, like, for example, on the seaside communication. So we are in a moment in terms of research and development that we have to face to provide contribution into distinct area. On the terrestrial network, we have the possibility of improving the current network by including massive MIMO, or as I said before, the reflective intelligence surfaces to improve the quality of the channel, or introduce millimeter waves for example, for increasing the spectral efficiency of the network, or to use for other type of bandwidth. On the other hand, we have challenges related to the non-terrestrial network. In particular, the main challenges are the size and the weight and the power constraint to the satellites, or the excessive delays in the communication, which are in contrast with the deployment of ultra-reliable latency communication, and also the energy constraint, as much as we already know about the UAV, and the mobility management and beam alignment of the satellites. So the problem is, so going back to this slide, we have a very complex scenario, and we need solutions that can address these current problems. So the question is, are the current conventional optimization able to address these challenges? So far, we are then at the stage where the network layer, meaning the IP layer, the service layer, are very well optimized. So the main focus at the moment will be how we can improve the radio access part of the network, which is the main part that provides the connection between users and the access to the core network. So this is becoming a very strict bottleneck in the network itself. And there are a lot of challenges that static rules or conventional complex optimization are inadequate to solve. Why? Because communication will going to be more complex, and there is the need of real-time solutions and the reactive policies, which is something that conventional convex optimization, for example, will not be able to provide. On the other hand, what is pushing now the research is the usage of artificial intelligence within the radio access network, which will gonna give very high possibilities for improving the performance of the network itself, since this can give possibility of intelligence optimization of the radio resource, dynamic and proactive traffic balance, and possibility to manage resource heterogeneous between heterogeneous devices, and meet then the stringent requirement of reliability and low latency communication. So under this perspective, a lot of consortium and a lot of alliances has been built recently, which merged together both a university and industry towards the standardization of the so-called Open Radio Access Network. So the Open Radio Access Network discussion has been started back in 2018, and since then, multiple vendors and multiple industry has joined the alliance with the main objective of create a radio access network which embed the principle of openness, intelligence, and cost effective. So the openness stands in the idea of having open interfaces, because so far the network are closed. And this, in a way, we're going to give the possibility of a small manufacturer and the small factories or small service providers to provide their own parts. So this will going to increase the competitiveness of the network and of the radio access network providers, which will going to reduce the cost, as I said before. But the more important is how the main question of the alliance is what are the main solutions that will going to provide intelligence in the network. So this is a brief understanding, a brief picture that we're going to show you the ORAN architecture. So the DRAN architecture can be implemented in different ways. One solution is provided here on the left side of the picture. There are all open interfaces which communicate with the orchestrator. And on the top of this orchestrator, I will not provide a lot of details. There is the intelligence, which can be divided into two main parts. The non-real-time radio intelligent controller, which we're going to provide optimization for requirements that are higher than 1 second, and the near real-time RIC for sensitive functionalities and large communication. So for services that requires latency that are below 1 second and close to 1 millisecond as well. And the main important thing of this architecture is that everything will gonna be distributed and decentralized according to the needs on the network. So this kind of architecture will gonna provide flexibility to the mobile network operators to rearrange their network according to the type of services that will gonna be provided. So basically, for those familiar with the network function virtualization and software-defined network, this is basically the same principle applied to the radio access part, but with the possibility of embedding intelligence with the AI. And the most important thing is that the non-real-time RIC and the near real-time RIC are both entities that can embed AI optimization-based protocols, so which can be put inside as plug and play. So they can be, every mobile network operators can decide which functionality to embed thanks to the open interfaces. And that one was the architecture for the terrestrial network, and the same thing is happening for the non-terrestrial network. Recently, the Alliance is exploring possibilities on how to embed openness and different architecture in order to guarantee the possibility to integrate the non-terrestrial network and terrestrial network in an open and intelligent approach. So, sorry, I just drink some water. So, what we will gonna put with the AI, we're gonna be, AI is data driven. So we're gonna need the policies are the majority of, well, so the main target is, as we said, that we need to introduce AI. So what we need to introduce AI? First of all, the training so far is doing offline. So we train our AI in order to in data that is being gathered before. So some data is being gathered before and is being used to train the AI system. But most of the time, this data is not full and is itself artificial data that not necessarily represents what will gonna be the real scenario on the networks, which is an unavoidable issue since the real networks evolve very quickly. So before we introduce AI effectively, what we need is possibilities for continuous training, more realistic data sets, meaning possibility for collecting data constantly, which is something that can be done with the DRAN architecture. And another important thing is, instead of using proactive policies, which means that the policies so far react when the issue appears, we need more reactive, instead of using reactive policies, meaning reacting to the problem, we need more proactive policies, meaning that the networks need to understand and predict what's happening and already have in place a possibility for address the issue that is happening, in order to guarantee specifically the low latency and the reliability of the network. So the main question is, on the left side, we have this issue to address and what we need to address on the right side. The main question now is how we can achieve this in both terrestrial and non-terrestrial network. As being the topic of the talk today, the most keystone technology that has been recognized as possible to address the issue before is the employment of the digital twin approach. So most of you already knows, but for those who doesn't know, the digital twin meaning having a real system which is digitally represented and is used to model the system behavior, and also gives the possibility to say how this evolves if we apply some policies without really impacting the real network. So, as I said before, the digital twin approach and what will consist. There will gonna be the network asset, which represents the physical layer. So in this case, on the figure on the right, I only represented the terrestrial network, but the same principle can be applied into the non-terrestrial network. So on the left side, we have the physical asset, which is the real network. Then this network, through a communication network asset, we're gonna collect data about the status of the network itself, the traffic condition, the quality of service requirements, and this network, as you can see here on the right side, we're gonna be represented virtually. And on top of this virtual replica, as highlighted on the box on the top, we can be possible to perform data analysis or design optimal decision policies or test optimal decision policies and provide offline training and real-time interaction with the network itself through AI capabilities. So, and this is perfect matching with the ORAN architecture, because the ORAN, what we're going to provide is at its core openness of interfaces, which we're going to facilitate the digital representation of the networks. And at the same time, the digital twin, we're going to provide the possibility of intelligence, which is another important aspect of the ORAN architecture. So as we can see here, there is a strong synergy between the Open Radio Access Network and the digital twin representation, because on the one side, the ORAN will require the intelligence that can be provided through the digital twin approach. And at the same time, the digital twin, in order to be represented, we're going to need open interfaces that we're going to facilitate the digital representation and possibility of data gathering. So, in this way, the digital twin will going to foster the possibility of opening the market to new mobile network operators and software developer, let's say, to provide the most suitable and high-level AI policies that can be trained into the digital twin using the digital replica. And once they are trained and well optimized, they can be deployed into the real system. So we have this strong working behavior between the digital twin representation on top of an ORAN architecture. So this is the point. We started with the problem of having the requirements for ultra reliable and low latency communication. How we can achieve this? We need the embedding of AI, but the AI at the same time, what we're gonna need? We're gonna need real data, possibility to training online and be tested before being deployed. And how we can do that? We can do that with the usage of digital twin, which means having a digital replica, which truly represents the network itself and can be used to train those AI policies that once they are rated and well tested into the digital twin, either offline or online, can be directly deployed into the ORAN architecture through the open interface. So, and as you can see here on this figure, there will be the possibility of having different applications that can be, in this case, application are AI policies that can be deployed into the RAN that has been previously trained into the digital twin replica. So as you can see here, there is a loop. We start from the physical network. We have the digital representation. In this digital representation, which is the digital twin, we can train and test our AI policies that once they are ready, they can be put in the open cloud, then automatically deployed into the open radio access network, which is the physical network. So, but of course, this is a good idea, but it does not come without challenges, which is a bad and good thing, good for us as researchers, because this gives us opportunity to investigate the possibility to address this issue. So what are the main issues? First of all is the digital twin. Okay, we have the digital representation, but what will gonna happen if some data that represents the system will gonna be missed into the system itself? It can lead to suboptimal, or in the worst case, not optimal solution of policies or applications that are deployed in the network that cannot guarantee the requirements of the network of itself. So this poor representation is one of the main issues. Also, the lack of data. So the representation and the lacking of data will gonna be the main issue in the digital twin representation of the network. So the other thing is how we're gonna guarantee the security of the data that is transmitted to the digital twin, because as I said before, the digital twin needs data to both provide a high fidelity representation of the network and also some data that we're going to be used from the AI to be trained. And of course, these are sensible data. So the other question is how we can guarantee the confidentiality and the secure communication between the data, and also how we can deploy securely the AI. How can we know that the AI trained into the digital twin application is the one that we really need? In this case, two main directions of research has been identified. The first one is the blockchain authentication for transmitting data from the real network to the digital twin, and vice versa, from the digital twin to the network itself. And the other approach that can guarantee secrecy and security in the process of training and deploying AI is the usage of federated learning, meaning that the local data is transmitted, not the entire data, but just some part of the local models, and the local data is transmitted to the core of the network. And on top of it, there will going to be an aggregator that we're going to merge these differences and create the entire AI approach or core software, as we want to call, that we're going to be deployed in the network. And the other thing that so far has been done by humans is how we're going to label the data that is necessary for AI. So basically, so far we have gathered the data, we have cleaned out the data, removed all the out layers, removing all the missing data. But if we want to adapt this to a digital twin representation and training in real time, we need some mechanism that we're going to be able to gather the data, classify, clean, polish, and send that to the AI. Because if we do not, and this is also another issue, because if this, let's assume that this process can be optimized, if the data representation is not accurate, it can lead to a training of the AI into the digital twin, which is not accurate and can be compromised. So these are the main challenges. So we have the main challenges of the digital twin representation and how we can address and what are the current direction. But the other core is how it should be the AI represented into the digital twin. Which type of artificial intelligence we need to represent. It must be centralized, it must be distributed, So one of the research direction on which I'm also working at the moment is using a hierarchical representation or hierarchical approach of the AI. So the main objective so far has been that there are policies that control the entire radio access network. To go back to the discussion. Sorry. So the main point is how we need to arrange these policies into our digital twin, how these policies needs to be represented into the digital twin. So one good approach is the hierarchical approach, which means that there are different levels and hierarchy of AI that can be divided into the master and the slave, meaning that there will gonna be the master AI representation or master AI policies that is being optimized for the long-term global decision. Then there will gonna be a middle layer of AI, which will gonna be used for the mid-term coordination of the policies. And then there will gonna be low-level AI that will gonna be used for short-term real-time adaptation of the network. So with this organization of AI architecture, the research community has identified this representation as the most promising for AI representation and application in the next generation networks. So, but the point is, yes, we can have this level of representation, but at the same time, this can work into the terrestrial network. But what about the non-terrestrial network? Because in non-terrestrial network, this has been already demonstrated. So the hierarchical approach has been already demonstrated for traffic steering, network slicing, and source location. But since in the next 6G vision, we need to add some other and address some other issues like large propagation delay, dynamic satellites movement, beam footprint variation, and energy constraint on board satellites. The question is, okay, is the hierarchical approach the best? So imagine that we are in a 6G scenario where we're gonna have both the terrestrial network with the O-RAN architecture, which can be in different ways. So in the first case, we're gonna have the terrestrial network, which is completely O-RAN, meaning that the O-RAN, the Open Radio Access approach, is applied in the terrestrial area, so in the most left side. And at the same time, we have a low altitude satellite that can communicate and works as relay of the network between the base station and the users. This is a relatively simple approach because what we need is just to know the position of the satellite and optimize the resource. But since we move from the left of this figure towards the right, we're gonna have a more complex network scenario. So for example, in this case, we have a high altitude platform where the centralized unit is in the terrestrial sites, while also some parts of the centralized and distributed unit is in the satellites, meaning that some resource allocation needs to be performed both at the same time on the terrestrial and non-terrestrial communication. So we do not only need to know the position of the platform or the satellite whatsoever for the purpose of beam steering, but also for the purpose of coordination. So this is the question is then, with this kind of approach, which is the most complicated and the most challenging, is the hierarchical approach enough? So imagine that we have, for example, in non-terrestrial network, we have to perform the model in this kind of communication where, for example, in the most right side, both the O-RAN architecture, which include centralized unit, distributed unit, and radio resource radio unit, are both implemented into the non-terrestrial network. So we need to perform the modulation, decoding, and bandwidth processing or also the scheduling of users to guarantee the quality of services. And we also need to coordinate the neighbors challenge and the neighbor satellites to provide coverage. So the question is, okay, as we said before, with the hierarchical approach, we can split these functionalities, but is this the real approach promising for the integrating terrestrial and non-terrestrial network? So imagine that we want to build a digital twin that can be used to represent both terrestrial and non-terrestrial network, and we want to develop policies on this type of architecture. Is the hierarchical approach the best? In this case, we're going to have to deal with dynamic topology, which is something that is not has been dealt into the terrestrial network. We also have to deal with decision latency and scalability and local optimality of the solution. So, which means that the solution that has been developed for one satellite configuration might not be the optimal representation of the digital twin for another type of network configuration. So recently has been the alliances that I mentioned before, like the Aryan, as gaining a lot of interest on the hierarchical but multi-agent reinforcement learning, which seems to be the same thing, but they are essentially different, because the hierarchical learning we're gonna provide the possibility of decompose complex problem and provide multi-scale management. The multi-agent, on the other side, we're going to provide distributed intelligence and collaborative behavior, meaning that there are different agents that can collaborate to reach the optimal policies and share the experience in terms of transfer learning to learn a new policies for a new scenario. And together, hierarchical and multi-agent must not be put on offline training, but they need to be trained through the reinforcement learning, which constantly take data, put the data into the digital twin representation. And with the reinforcement learning, this will provide the convergence towards the optimal policies. So at the end, this will gonna be the architecture of the hierarchical multi-agent reinforcement learning. So what we're going to provide, this approach is proved to be versatile, scalable, decentralized, and distributed, which are the challenges that we saw before in the previous slide when we were going to integrate terrestrial and non-terrestrial network. So there were going to be an high-level deep reinforcement learning that we're going to manage the slow scale. And there were going to be also multi-agent. These are high-level deep reinforcement learning. In a hierarchical way, we're going to be translated into short-term priorities. And these short-term priority constraints, using the multi-agent deep reinforcement learning, we're going to divide the policies. So there were going to be different agents for each part of the run. One for the physical layer, one for the medium access control, and one from the radio link control of the run. So this physical run radio access network, which represents the effective network, which can be either the terrestrial and non-terrestrial network, we're going to provide service to devices. These devices we're going to provide the feedback to the digital twin. And again, this will going to be the loop on how implementing hierarchical multi-agent reinforcement learning into a digital twin approach for the next generation networks that, as I said before, can be used for both terrestrial and non-terrestrial network. So these are some possible use cases like dynamic spectrum allocation that we're going to help to reduce the interference, for example, in this case, between the service provided by the drone that acts as relay between two base stations, and interferences between the base station and the satellite that providing service into a non-covered area. So in this way, the hierarchical multi-agent reinforcement learning will going to provide the spectrum efficiency and reduce the interference. Another approach will going to be the possible handover management of the service on the network. So in this case, the approach will going to provide reduce the drop connection, so meaning high level of quality of services, and lower handover latencies that can compromise as well the ultra reliable and low latency communication. And finally, the possibility of load balancing between terrestrial and non-terrestrial network, which again, will gonna provide a balanced resource utilization, improve the network throughput, meaning high level of throughput in the network, low latency in the communication, and also reliability, because in this case, we can go now, for example, in the case like when we have an heterogeneous network, we can have the possibility through this approach to design the agents in our digital twin that can contribute to the achievement of the optimal policies in the network. And what are the current contributions? The current contribution is that even though this hierarchical multi-agent reinforcement learning has been start to be approached, it can converge also for local, meaning in a wide site, local for just 2 or 3 satellites at the same time, while there are some satellites and some network, for example, in this area that can be slightly overlapped. So there is the possibility of investigate how to perform policy sharing and learning synchronization between different terrestrial and non-terrestrial network cores, for example. And also another thing that we're gonna make the difference is that there is the convergence issue on the policies. Sorry if I'm speedy because I see that we're running out of time. So, but I'm open to question later. So there is the need of addressing the speed of convergence into the non-terrestrial network representation, because there will gonna be latency between the satellites communicating the network status to the digital twin, and this lack of synchronization, as we said before, cannot lead to the optimal solution. And at the same time, for the terrestrial network, since for the terrestrial network, we have a quite mature digital representation of the network, but there are challenges on how we're going to represent the digital twin of the non-terrestrial network. So in this case, there are the 3GPP is providing models for modeling the channel communication between the satellites and the terrestrial network, but this does not necessarily represent the real channel. So there is a need to investigate a more accurate digital representation for the non-terrestrial networks, since the communications can be compromised by by rain fading variation and limited availability of data. And at the moment, the digital twin representation for the non-terrestrial network is something that is very simplified compared to the real approximation. So there is the need of collaboration between industries and the researcher in order to work around how we can provide a more accurate representation for the non-terrestrial network digital twin representation. So with this one, I hope that I didn't want to talk too much time. So thank you very much for this opportunity of the presentation. Here there is the QR code of my page if you want to contact me and check my presentation, my publications. And now I'm open to questions and very looking forward to receive your questions. Thank you very much.
Thank you, Dr. Antonino, for a very engaging and insightful presentation how digital twin and AI can help realize the vision of 6G. So we now move into the QA section.
Okay.
So I don't see any question from the chat box. So for the audience, the attendees, if you have any question for the speaker, feel free to unmute, raise your hand, and give the questions directly to the speaker. So while waiting for the question from the attendees, Antonino, I have a question for you. So it's a very interesting the hierarchical approach, optimization approach to deal with the resource allocation in non-terrestrial networks, 6G. So how can we apply this approach in the practical situation? For example, we have long-term problems, short-term problems. So can you give us some detail about which kinds of the control or decision control we need to apply the long-term optimization, and which kinds of variable we need the short-term, and how can we integrate these approach in a closed loop digital twin for real-time decision making? So that's my question. Yeah.
Yeah, thank you very much. This is very good question. So in terms of long, as you can see here, like I go back to the slides in a second. So as I said here, for example, the main architecture we're gonna be here like long-term decision. So we have, for example, quality of service and rates or latency requirements or energy efficiency requirements that we need to guarantee either in the terrestrial and non-terrestrial network. So we start with this, and the main point in this way is how we can guarantee. The way to guarantee this is to develop proactive policies, meaning that using the data that we have, we need to predict what we're gonna be in the next 10 milliseconds, 20 milliseconds, what will gonna potentially be the network condition. So based on this proactive rather than reactive, we can predict what will gonna happen, and in the digital twin itself, we can start to train our model to adapt to the potential change in the network. So once the model is trained into our digital twin, so he knows what we're gonna be, for example, the channel condition in the next few milliseconds, or what will gonna be the mobility of the users, which is something that can be done with the integrated sensing and communication. Is also another important aspect of the digital twin that I forgot to mention. So we have possibility to track users, to track their mobility, to track their speed. So we know we can predict where the user will gonna move and how the satellites also will gonna move. And based on these constraints, we can develop proactive policies that, based on those predictions, we're gonna transfer this to the network, and the network is already ready to apply this if the condition that we predicted that are gonna happen.
Thank you very much. It's very clear to me. So I have one more questions about the security issues. So you mentioned that security is very important in digital twin system. So how can are there any problem in security, and how can we mitigate the security risk in this kind of system?
Yeah, the security in the digital twin representation is mainly related to guarantee the secrecy of the data, meaning that no sensitive data can gonna be revealed from the transmissions, because as we said, we need some data to do some prediction from the users. But at the same time, we have to guarantee authentication, because there can be some attack known as data poisoning, for example, that can intentionally put some altered data that is used for the training, and using this altered data that can compromise the network itself, meaning that the training that we are performing in the digital twin is done on compromised data, and this compromised data can lead to policies that can either disrupt the network or can provide access to the attacker, meaning that the attacker knows with data poisoning, said, okay, if I inject this will gonna happen in the training, so this potential will gonna open possibility for me to attack the network further. On the other side, when we transmit the policies back from the digital twin to the network, we also need to have an authentication to be sure that the software that we are installing into the physical network is the real one that we are receiving from the digital twin. Because there can be also in this case like the man in the middle attack, where there are going to be an attacker in the middle that when he identifies that the AI training in the digital twin is going to be transferred into the network, he impersonified the digital twin itself and say, okay, this is the new policies that needs to be applied in the network. And this is something that is not good. So we need a way to be sure that the data cannot be compromised with data poisoning. And at the same time, we need to be sure that the policies are effectively coming from the digital twin and not from an unauthorized party.
So, thank you very much for your answer. So we have a question from the audience. Mr. Talk, he said, you can read directly from the chat box. Thanks for the presentation. He has 2 questions.
I read it. So thank you very much. So the first question is, what factor influences the replication process from a physical system to a digital twin? Okay, I will answer. And the other question is, what metrics should we consider for evaluating digital twin in 6G networks? So to answer to the first question, the main factors that will gonna impact the digital representation of the networks, first of all, it depends on the type of representation. If we are solely representing, for example, the terrestrial network, we just need to represent the CPU of the network, the occupancy, the rates that all the devices for the processing of the data, the amount of traffic that particular slice of the network is facing, and what are the quality of service requirements that the users are requesting, what is the amount of bandwidth that we are available to use, and how much is the processing that we have availability that we have in the real network. But when we move to the non-terrestrial network, the other data that we need to know from the satellites is, for example, in the case of the UAV, how much battery the UAV has, which one are the areas that the UAV needs to cover, or for example, which type of antennas like the UAV has. Well, what is the functionality? Using as relay or is using like not just a service provider? And the same thing for the satellites, and say, okay, which satellites we are using, which satellites can collaborate each other, and what is the path of the satellite. So in order that we can plan handover in the network. So this is also partly the answer to the other question, which means which metrics should we consider for evaluating digital twin in 6G networks. So we need to evaluate the quality of service requirement. We have to evaluate the fairness of the users. We need also to evaluate which type of reliability we need to guarantee. And also in terms of data representation, we need to guarantee the age of information. How old is the data that we are receiving to represent our system? It's recent, it's very late. So we have to reduce as much as possible the age of data into the system. I hope that I answered to your questions.
I think this will be very informative answer. So we have one more. He have one more questions from the attendee.
Yeah, I saw. So it's about the hierarchical multiple agent assessment. How exactly does your high-level policies and control to the low-level agents as goal, a constraint, or reward signal? And can the two levels be trained separately or only jointly? Okay, this is a very interesting question because it's an open research challenge. So there are a lot of possibilities that can be investigated in this part. So one way, of course, which is the classical, is we can train them independently, but the main essence of hierarchical is that the models needs to be trained together. This means that not fully together, but the feedback loop that we have from the physical network to the digital twin needs to be implemented partially between the agents, meaning that, for example, in the case of the actor and critic, just to give an example, but will be more complex than this, we have the actor that takes the action, and we have the critic that will gonna provide the feedback and say, okay, you need to adjust the policies in this direction. So if we are going in order to in order to apply the hierarchical multiple agent reinforcement learning, we need to necessarily guarantee a strict feedback loop between different level agents. So for example, the high level policies will gonna monitor how the quality of services or the rate needs to be, for example, in the next 10 milliseconds. Then we're gonna give these policies to the low level, like the short term, which we're gonna apply some other actions. Based on that action, the loop will gonna tell what happened to the real network, and then we're gonna be the high level agent that will gonna give instruction to the low level agent to adjust itself in order to guarantee best policies. I hope that this answers to your question.
Yep, thank you. So again, anyone from the seminar, do you have any questions? Want to give directly question to the speaker? Feel free to raise your hand. Tuấn Lê, yep, I see here, Dr. Tuấn, and you open.
Yes.
Yep.
Yes. Thank you, Antonino. So thank you for the informative talk. Could you elaborate on the problem that because we have a digital twin system, is going to introduce some delays because it needs to exchange the data from the digitals and the physical aspect. So how would we address the problems when we have low latency constraint on the system?
Yeah, this is thank you very much for the question. So this is why I said that we need the proactive rather than reactive policies. So there is at the moment the need of more data. What we can do, in my opinion, on what has been done can be done is using the limited availability of data and use generative AI to increase the data, so expand the data. And based on the expanded data, we can, instead of designing reactive policies, meaning that this is the state, this is going to be the action, instead of doing the action into a current state, we can predict what will going to be the state and say, okay, from this state, we're going to move in the next state in the next 10 milliseconds or in the next, let's say, 1 millisecond, and say, okay, we're going to move there. And based on the data that we're going to have at the moment, we can predict what will going to be the next channel condition, the next quality, the next user mobility. And using that, instead of designing the reactive, so we have to wait, because so far what happens is that we have to wait until a specific condition happen before reacting. So if we change our approach and we move from reactive to proactive, we can predict what will happen because we have some availability. Even if it's limited, we have some availability of data that can help us to predict what can happen. And from the prediction, we can already put in place the solution that not necessarily we're going to meet the perfect, but something that is meet as much as possible the upper bound, let's say, of the qualities that we can guarantee. So I recognize that there is the lack of synchronization, but using generative AI and using proactive policies into the digital twin, I'm sure that we're going to be able to provide better policies for guaranteed low latency and fight, let's say, the issue of lacking of data and synchronization between physical and digital network.
Thank you so much. Thank you.
So I don't see any new questions. So I have, maybe this is the last question from my side. So here, Antonino, we have many undergraduate students.
Okay.
They are starting to study, to research, to do the projects on digital twin and networking, something AI for digital twin system. So do you have any advice for students? How can they get started with this topic? Because as you presented, we did the data from real test-bed or system, but for 6G and 5G system, we don't have any equipment or real test-bed here. So how can the student approach the data set, and are there any practical simulator or any tool the student can use for their project?
Yes, of course, there are different tools, so not necessarily, because not necessarily everyone has to have physical equipment for conducting research, and sometimes the availability of data is not that much, but I can guarantee that there are online some repository depending on the topic that you want to investigate. Like, for example, I can share this. Sorry, I didn't invent this, but I can share with you. There are some links about data collected. For example, I had one of the undergraduate students that conducted a project here, which was on Challer prediction on mobile network operators within the UK. So there is the availability of this data set on where to collect the data, which has been really collected across different mobile network operators. And through this project, the students use that data to perform predictive, to conduct a project on how to predict the channel condition on the next millisecond, or the next 2 milliseconds, for example. Or there are some other repository that can be used for tracking the mobility of users, that can be used, for example, to design AI policies for predicting the position of users, either vehicular and non-vehicular, and then in the aim of providing like the proactive approach that I was saying before. And there is also some other simulators like Siona, developed by NVIDIA, that can be easily downloaded online from GitHub. That is a very good modeling using AI for the channel representation of the network, for example. So this is a very effective tool that can be used. It's based on the 3GPP channel modeling, but with the usage of AI has been improved to provide a more reliable representation of the physical condition into the network. So it's a ray tracing. It's not a multi. So this can be used for research activities for the students. So I suggest to do research on digital twin, both physical and non-physical part, but do not get, do not be scared that you need a lot of data, because in the past the data was not available, but now with the days, if we check online, there are some more open repositories that can be used for user mobility or channel modeling or data or channel collection, channel measurement collection.
Thank you. It's very very helpful. I think these kinds of data very helpful for students. So here I don't see any questions, so we can and we come to the closing. So again, thank you, Dr. Antonino, for your comprehensive and insightful talk, and for generously sharing your time and expertise with us today. So this also brings us to the close of our three-part UK Vietnam T&E webinar series on emerging technology. So over these three sections, we have explored quantum computing, 6G, intelligent connectivity, and today, digital twin and AI for 6G. So these the three areas that will shape the future of computing and communication. So on behalf of the UIT, the team from UIT and Middlesex University, I would like to thank on the speaker across the series and our organizing team, and most importantly, all of you who joined us, ask a question and engage actively. This series has been made possible through British Council Going Global Partnership 2025 program, supported our UK Vietnam T&E collaboration. So we hope it gives you a valuable news perspective, and we are looking forward to continuing this partnership in the future activity. So before we close this section, Dr. Tuấn, do you have you want to say something about our project and the next activity, the plan for our next activity?
Thank you very much, Antonino, and the audience, and thank you for organizing this amazing talk. Yes, we have a series of webinars, and our next activity would be organizing a workshop in the UK and Vietnam. So hopefully this summer, Dr. That can come over and we are going to organize a workshop. I hope Antonino can join us for the coming workshop in Middlesex again.
Thank you very much.
So once again, thank you very much for the time and encouragement to the webinars. Thank you very much.
Yeah.
Thank you very much again for this opportunity.
Yeah. Thank you, everyone.
Thank you.
Have a wonderful rest of your day, and goodbye from Vietnam.
Goodbye.